For thousands of years, humans searched for one mysterious substance buried deep beneath the Earth's surface. A substance so powerful that it built cities, moved armies, transformed economies, and became the invisible fuel behind modern civilization. But the strange truth is the liquid that powers your car does not come out of the ground as gasoline. It does not even come out as a usable fuel. When crude oil first rises from thousands of meters below the Earth, it is a dark, heavy mixture filled with hundreds of different chemicals, unwanted gases, water, salt, and impurities. In its natural form, it would destroy a modern engine within minutes. How does this dirty underground liquid become the clean fuel that moves billions of vehicles around the planet every single day? The answer involves enormous drilling machines hidden beneath oceans, extreme temperatures, massive industrial towers taller than skyscrapers, and chemical processes happening at a molecular level. And the most surprising part is that one barrel of crude oil does not simply become one product. It becomes a collection of dozens of different materials that surround your entire life. The fuel in your car, the plastic in your phone, the asphalt beneath your feet, even many of the materials inside hospitals, all begin with the same strange journey. A journey that starts millions of years ago, long before humans ever existed. Deep beneath ancient oceans, microscopic organisms lived, died, and slowly sank to the seabed. Layer after layer of organic material accumulated, trapped beneath mud and sediment. Over millions of years, heat and pressure transformed these remains into a substance called kerogen. Then, under the perfect combination of temperature, pressure, and time, nature performed a chemical transformation. The result was crude oil. But this oil did not collect in giant underground lakes like movies often show. Instead, it became trapped inside tiny spaces within rocks, almost like water trapped inside a sponge. The challenge for humans was not simply finding oil. The challenge was reaching it. For decades, the easiest oil deposits were discovered close to the surface. But as global demand increased, engineers were forced to move into more extreme environments. The ocean became the next frontier. Far from the coastline, beneath freezing waves and violent storms, some of the most valuable oil reserves on Earth were hidden under the seabed. The North Sea became one of the greatest engineering challenges in modern history. Here, companies searched beneath hundreds of meters of ocean water, then drilled thousands of meters deeper into the Earth. The conditions were brutal. Winds could reach hurricane speeds. Massive waves could strike offshore structures with incredible force, and every piece of equipment had to survive years of non-stop operation in one of the harshest environments on the planet. But engineers built something extraordinary: offshore oil platforms. These giant structures are not simply factories floating on water, they are entire industrial cities. Some platforms contain living quarters, restaurants, control rooms, power systems, helicopter landing areas, and complex drilling equipment. Hundreds of workers can live there for weeks at a time while extracting resources hidden far below the ocean floor. But reaching the oil is only the beginning. The first challenge is drilling through layers of rock that formed over millions of years. A massive drill bit rotates thousands of meters below the surface, cutting through stone while special drilling fluids circulate through the well. These fluids cool the drill, remove broken rock, and stabilize the pressure inside the hole. Without them, the entire operation could become dangerously unstable. Because underground oil reservoirs are not simple holes filled with liquid, they are complex geological systems where pressure can suddenly change. And this creates one of the greatest dangers in oil production: a blowout. If underground pressure becomes uncontrollable, oil and gas can rush upward with enormous force. To prevent this, engineers use a device called a blowout preventer. This enormous piece of equipment acts like a giant emergency lock in seconds. It can seal the well and stop uncontrolled flow. A device that weighs many tons may be the only thing standing between a controlled operation and a catastrophic accident. Once the well reaches the reservoir, the real extraction begins. But the oil underground is not ready for transportation. It arrives mixed with natural gas, water, and other substances that before the crude oil leaves the platform. It must go through its first transformation. The gas is separated, the water is removed, the unwanted materials are filtered. Sometimes the gas is used immediately to power the platform itself. The same energy source that came from thousands of meters underground helps operate the machines, bringing more oil to the surface. But the journey is far from over. The cleaned crude oil must travel hundreds of kilometers before reaching a refinery. This is where another incredible engineering system begins. Under the ocean floor, thousands of kilometers of pipelines connect offshore fields with processing facilities on land. These pipelines must survive enormous pressure, corrosion from seawater, and the constant movement of the ocean. Every section requires careful engineering because one failure could create a major environmental disaster. Eventually, the crude oil reaches a refinery. And this is where the transformation becomes truly incredible. A refinery does not simply clean oil, it separates and rebuilds it. Inside these massive industrial complexes are towering structures called distillation columns. Some of them rise higher than apartment buildings. The process begins by heating crude oil to extremely high temperatures. As the oil heats, different molecules begin separating because every component has a different boiling point. The lighter substances rise higher. The heavier substances remain lower. At the top, gases such as propane and butane are collected. Further down, gasoline components appear. Below that comes jet fuel, then diesel, and at the bottom remain the heaviest materials used for products like asphalt and industrial fuels. It is almost like a chemical sorting machine operating on a gigantic scale. But even after the separation, the fuel is still not ready because crude oil contains unwanted elements, especially sulfur. Sulfur creates pollution and damages engines. Refineries use additional chemical processes to remove these impurities. Hydrogen treatment and advanced catalysts break down harmful compounds and create cleaner fuels. But there is still another problem, that a simple refinery process does not create enough gasoline. Historically, only a small portion of crude oil naturally becomes gasoline. As automobiles became more common during the 20th century, demand exploded. The world needed a way to produce more gasoline from every barrel. This led to one of the most important breakthroughs in petroleum engineering, catalytic cracking. The idea is surprisingly simple. Heavy oil molecules are long chains of atoms. Imagine them like giant trains carrying too many cars. Catalytic cracking breaks these long molecular chains into smaller pieces. The train is divided into shorter sections. The result, heavy crude oil components can be transformed into lighter fuels like gasoline. Inside special reactors, temperatures and catalysts create chemical reactions that happen in seconds. A substance called zeolite helps guide these reactions without being consumed. It acts almost like a microscopic tool that helps rearrange molecules. Without this process, the modern fuel system would look completely different. But gasoline is only one part of the story. A single barrel of crude oil creates much more than fuel. It produces chemicals that become plastics, synthetic fibers, lubricants, solvents, and countless industrial materials. This is why oil became so important. It was never only about transportation. It became the foundation of modern manufacturing. A phone case, a computer component, a medical device, a piece of clothing. Many everyday objects have a hidden connection to petroleum, but this dependence also created enormous economic and geopolitical consequences. Because oil is not just a resource, it is a global power system. The price of fuel depends on production levels, international conflicts, transportation costs, and market expectations. A decision made thousands of kilometers away can influence the price people pay at a local fuel station. When supply changes, entire industries feel the impact. Airlines, shipping companies, manufacturers, farmers. Almost every sector of the global economy is connected to energy prices, and this brings us to one of the biggest questions facing the world today. What happens when these resources become harder to access? Every oil field has a life cycle. At first, production is easy. Natural underground pressure pushes oil toward the surface, but over time, pressure decreases. Water levels increase. More advanced technology becomes necessary. Engineers inject water or gas into reservoirs to push remaining oil upward. These techniques can extend the life of a field for decades, but eventually, every reservoir reaches a point where extraction becomes too expensive. This is what happened to many famous oil fields around the world. Some fields that once produced hundreds of thousands of barrels per day slowly declined. The same technology that created enormous energy supplies also revealed a difficult truth. Earth's resources are limited. Today, the oil industry is changing. New drilling technologies allow access to previously unreachable reserves. Digital systems monitor wells in real time. Artificial intelligence helps optimize production. Engineers are finding ways to extract more from existing fields while reducing waste. At the same time, the world is searching for alternatives. Renewable energy, electric transportation, new storage technologies. The future of energy is being rewritten, but even as new technologies emerge, oil remains deeply connected to modern life. Because the story of oil is not just the story of fueled, it is the story of human engineering, a story of turning ancient biological material into energy that moves civilization, a story that begins in darkness, thousands of meters underground, and ends with a simple action, a driver turning a key, a plane taking off, a factory starting its machines. Every drop of fuel carries a journey that lasted millions of years, from ancient oceans to underground reservoirs through massive industrial machines and finally into the world we built around it. The next time you see a vehicle moving down a highway, remember this. The gasoline inside it is not just fueled. It is the final chapter of one of the most complex transformations humans have ever created.